Yes, welcome to Mathematics Grade 10. Mathematics Grade 10 for the 14-day period, and the topic that we want to look at is what we call inequalities, or the correct term, inequations. Topic is inequations. And what is inequations? In the corner here, you see we give you some symbols that you see here is called the greater than sign, the less than sign, and this one is called the greater than or equal to. This one is called the less than or equal to. So we're going to go into what do we mean when we say greater than. All right. So for instance, if I have let's fix that good, x greater than 5, x greater than 5, that means that x has value from 6 go up. So 5 would not, if x is greater than 5, 6, 7, 8, 9, 10 to infinity would be a value of x. Right? Right, so all the value of x would be greater than 5. So 4 cannot be a part of it because 4 is less than 5. So let's look at this. Y less than 4. Y less than 4 says that 4 cannot be a part of it. 5 cannot be a part of it because I said y less than 4. So the value like 3, 2, 1, 0, -1, -2 to infinity is a part of it. It's a part of the set y less than 4. But if you have x greater than or equal to, say, 6, then this is saying that x is equal to or greater than 6. So that will be 6, 7, 8, 9, 10. So it's when you have the equal to sign, 6, the number that is given, is a part of it. So 5 cannot be a part of it because it's less than, and the sign says x is greater than or equal to 6. Right? So the next one, less than, so y is less than or equal to, say, 3. What that is saying that y has the value 3 and number less than 3. So 4 cannot be a part of it, 5 cannot be a part of it, 6 cannot be a part of it. It has to be 2, 3, 2, 1, 0, -1, -2, all the way up to infinity. Those are the number part of it. So that is what we're talking about. The sign here, less than, greater than, less than or equal to, greater than or equal to. Now, I want to look at when we divide all the sign changes when we divide by a negative number. For instance, if I have -4 less than 2, if I should divide these two numbers by a negative number, I should divide these two numbers by a negative number. I should divide these two numbers by a negative number. Then it will look something like this. Upon negative 2, 2 upon negative 2. Something happens. So it's a negative times a negative will give you a positive, right? So this will become positive 2. And this is a negative times a positive will give you a negative 1. But something happened with the sign. If you notice, 2 is greater than negative 1. So you could not use back the same sign. You have to change the sign. The sign are going to give you the reverse. Right? So that is 2 greater than negative 1. And that is for all inequalities. When you're dividing by a negative number across the inequality, then the sign changes. Then the sign changes. So the next step we want to look on is an equation where we have, let's look at this one, negative 3x plus 7 plus 7 equal 8. No, let's give a bigger number. Give a bigger number. So say 28. Right? So negative 3 plus 7 equal 28, and we want to find the range of values of x. Well, I have equal sign here. Let's say that it is less than, or equal to 28. So negative 3x plus 7 less than or equal to 28. Yeah, that's an inequality question. We want to find the range of values of x. So we have to transpose to make x the subject of the formula. And then we can solve for x, and that would have satisfied the maths. And look at the process. So the first step we want to do is to move the 7 here and take it over the inequality sign. First, you know that it's a positive number. Once it goes over the inequality sign, it's going to become negative. Right? So it's going to become now negative 3x less than or equal to 28 minus 7. Right? So we can just calculate that out. So it's going to be negative 3x less than or equal to 28 minus 7, that's 21. Right? Right. So now we are at the negative sign. We're going to divide through by a negative sign like before. So when we move this negative number I said negative 3 times x. So we're going to do the opposite of multiply and divide. So this is going to become now negative 3x, right, upon negative 3 less than or equal to 21 upon negative 3. Alright, let's some space. Alright, yes. So when we tally this up now, this is our cancel out. So this is going to become now, this cancel this. This into itself 1, this into this goes 7. So what you have left is x. The sign are going to change, right? Because you divide through by a negative 1. So this will become greater than or equal to 7. So that's the point we're making at the top, where we said that once you divide through by a negative number, the sign will change. And this sign here, when you divide through by a negative, this is negative 7. So x are going to equal to negative 7. Alright, to satisfy. Allow us to do one more example, and then we will take it all home. Alright, so another example would be 4x minus 5 equal to 20 15. That's right, 15. 15. And let this be greater than, because we're talking about inequality. Greater than. Right? So 4x minus 5 greater than 15. And we want to solve for the range of values of x. So like this is a minus number here, so when we take it over the inequality sign, it's going to become plus. So this is going to become now 4x greater than 15 plus 5. We tally that up, that is going to be 4x greater than 20. Right? So look, there's no minus there in here, so when you divide through by 4, we're not going to change the sign. Only when a negative is at the end here, we change the sign. So this is going to equal to 4x upon 4, 20 upon 4, upon 4, and the equation, let's simplify that so that 4 into itself 1, 4 into itself 1, so what left is x. 4 into itself 1, 4 into 20, or 5 times. So therefore x is greater than 5. X is greater than 5. X is greater than 5. So let's write that x greater than 5. Sorry, I put a 2 here when it should be a 5. And that will satisfy that equation. Now, when we talk about that in a number line, how it would look. So if I have a number line and I want to represent x greater than 5 on the number line, x greater than 5.